Hi friends, in this video we are going to discuss about the Venn diagrams. So basically it is a one method, one way to represent sets and their subset, a relation between the sets and subsets. So most of the relationship between sets can be represented by means of some diagrams like rectangles, circles. These are called Venn diagrams actually. These were discovered by the English logician John Venn. So this diagrams names are given after him. Okay, here figures are there, some shapes are there which are used to represent sets. So universal set here represented by the rectangle and the subset are represented by the circles. So here you can see this is one rectangle, it shows universal set. It is a collection of all the elements present in its subset. Okay, it's a larger form of sets. Like this, in this set we can see here there is a rectangle which shows the universal set. In that elements are there 1 2 3 4 5 6 7 8 9 10, means till 10, or it is a set of all natural number, not all, it's a set of natural number less than equal to 10. Okay, because natural number start from 1, right? And here A represents one circle. It's not a subset of universal set U. Usually universal set we represent by letter U, capital U. Okay, so how many elements are there? 2 4 6 8 10. These are the elements which are present in the subset A, which is inside this rectangle. It means if any circle is inside the rectangle, it means it belongs to this universal set. This is the subset. A is a subset of universal set. Okay, so you understood now what is a universal set and what is Venn diagram and how they are related to each other. Not only one subset, there we can represent many subsets with the help of Venn diagram. As we can see here, there is a one circle, bigger circle, in there 2 8 10 elements are there. Another we can take, another we can see, this is small circle, this is a small circle. Okay, it is another subset. So B, its name is B. So there are two subsets. Now we can say, and both are enclosed inside the rectangle, which is a universal set. So in this universal set, all the elements, it is a universal set in which all natural number which are less than equal to 10 are present. Okay, and here A is the subset. A is the subset of U. A is the subset of U. Okay, because here elements are present 2, 8, 4, 6, 10. These are elements present in the A. But inside the A, one more small circle B, in which is there 4 and 6. So we can say B is subset of A. Clear? Even B is subset of A, but B is subset of U also, because anyhow B also belongs to U only. Okay, so this is how we can represent sets in the form of Venn diagrams. Now we will learn operations on sets. Okay, so operations means like mathematical operations. We have addition, subtraction, multiplication, division. Same way we have some operations like some what you can say, grouping of sets, separating of set, keeping separate element. These are all called operations. Okay, so first one is a union of sets. Okay, so union means combining, mixing, combination. So whenever two sets A and B are there, if we combine their elements, this is called union. And since it is a beginning with the letter U, so we can use capital U to represent union. So if we combine elements of A and B, we can write A union B. A union B. This is the representation of two sets, union of two sets. We can see here that one set is there A 2 4 6 8. Here another set 6 8 10 12. Two sets are there. If we combine their elements, we get 2 4 6 8 10 12. But remember that element should not be repeated. If both the set have same element, this element should be included only one time. 6 also repeating, so we included in the union only one time. 6 and 8 are used only one time. We cannot repeat them. This we have to remember. Okay. Same manner, another example also is there. So no need, we will solve in the exercise. Then I will explain you. Okay. Now we will see some properties of union. What are the properties of union? Properties of operation of union? See, commutative law. They follow commutative law. Like we have studied commutative law in the whenever we were learning rational number, we were learning natural number, even integers. That time we have learned. So when like we add two numbers like 2 plus 3 and 3 plus 2, in both cases answer is same. Okay, if we change the order of number, but it belongs to integer only, right? So for the integers, commutative property is applicable. Correct. For the addition, not for subtraction. Subtraction is not applicable. Same way here, commutative property is applicable for union. If we do A union B or B union A, both the cases, the set which we will get after the union, it will be same, right? Like we can take two sets here. Like we have a this one, we can take example X. X1 set here Ram, Geeta, Akbar. Y1 set Geeta, David, Ashok. If we do, suppose if I am taking this X, sorry, one second. So if I use a X union Y, it will be Ram, Geeta, Akbar. Sorry, it is one second, it is removed. I'll write it again. So Akbar. Take Ram, Geeta, Akbar. If I take Y union, one second, Ram, Geeta, Akbar, one second. So X union Y, it will be Ram, Geeta, Akbar, comma, in the set Y, which elements are present? Ram, Geeta, Y, Geeta, David, Ashok. So Geeta has come one time, so we'll write only one. We will not repeat it. Okay, Geeta has already done it. It is a common element of both X and Y. So we'll write David. They are not present in X, and Ashok. Clear? So these are elements of X union Y. If we do Y union X, what will be the result? Let's check. Y union X. So here first we will write Y elements. Geeta, David, Ashok, comma, Geeta is repeated in the X. So we can write Ram, comma, Akbar. But both cases elements are similar. Okay? So we can say X union Y and Y union X. It follows the commutative law. Now we'll discuss another property, that is associative law. It is based on three sets. If you first combine A union B, like we have learned associative property of integers, rational numbers, right? Here we will do associative property of sets. If we combine or we do union of two sets A union B, after that union, if we do union of C, that will be equal to, if we will combine both the element of B union C and then we combine A union B. Okay? So this follows the even associative law. Suppose I will take one example to explain this. I have one set A. Its element are A, comma B. Okay? Another set, one second. Another set B. Here elements are C, comma D. One more set I am taking C. Its elements are E, F. Now first I need to do A union B. A union B. That means A, B, C, D. I mean combining both the elements of A and B. Okay. Now I have to do union C. This A union B, and there that should be combined. One sec. Element C. So A union B. What is A union B? This one. A, B, C, and D. Now we have to combine with the C. So elements of C, E, F. Right. So A union B union C is A, B, C, D, F. Clear? Now first I will do B union C. B union C. So B union C will be, what the element of B, C? C, D, E, F. C, D, these are the element of B. E, F. These are elements of C. C, D, E, F. This is the B union C. Now B union, one sec. A union B union C. Sorry. Union C. So first I will do union of B union C, that I have done. After that I have to combine B union C with the A. So elements of A. Elements of A. So element of A, we have AB, A, comma B, and element of B union C is C, D, E, F. Now you compare these elements, A union B union C and A union B union C. Both cases elements are similar. So we can say it follows the associative law. Now we'll see A union Xi. Xi represent empty set. Empty set means the set which does not have any element. That is called empty set. Okay. So A union Xi is equals to A. This is also called law of identity element. So if we union any set with the empty set, there will be no change. Set will be itself as it is. Now A union A. If we combine elements of one set to again its element, that will be same set. That is called idempotent law. So as we know, a universal set we have to represent by rectangle. One set A and another set B. Now we have to check that if they have common element, we have to cross them. We have to cross them like this. So this area represent intersection. Okay, this area represent intersection. But if we want to represent their union, means combination, then we have to shade complete both the sets. We have to shade this part, represent this complete part which is shaded, which is called union. At the same time, if we take only common part, as we have seen in this set A and B, so this part we can check, blue color part, this one, this part, it is represents common part, intersection. So with the help of Venn diagram, we can represent A intersection B in this way and A union B in this way. Mean this full is shaded. This represent A union B.